Good morning. Today we're going to begin a review before we head into Chapter 9 Trigonometry in the Algebra 2 book. We are going to go back and review 4 areas that you had learned back in Algebra 1 and reviewed again in geometry. We'll go much deeper in depth in Algebra 2 on these concepts. Let's begin with Pythagorean's theorem. I've listed when to use these. So in this particular case, we want to use Pythagorean's theorem when you're given 2 sides and you're trying to find a third side. No angles are given. The terminology, we call the 2 sides that form the right angle are called legs. The side opposite the right angle is called the hypotenuse. Instead of learning just a squared plus b squared equals c squared, let's use leg squared plus leg squared equals hypotenuse squared. When you write this, hypotenuse has to be on the side of the equal sign all by itself. I provided 4 examples. Let's look at the first one. The 2 legs were given as 4 and 3. So we put the x on the side by itself. X squared equals 3 squared plus 4 squared. Simplify gives us 9 plus 16 is 25. Take the square root of both of the sides would give us that x is equal to 5. Same type in the second example. 2 legs are 4 and 6. So we set our equation up again. X squared equals 4 squared plus 6 squared. Multiply those out, gives us 16 plus 36 is 52. This time when you take the square root, you have to simplify that radical. Square root of 52 can be broken down into the square root of 4 and the square root of 13. Square root of 4 is then 2 radical 13. You do have to simplify all of your radicals. In the third example, we have the hypotenuse and one of the legs are given. So this time we have x squared plus 3 squared equals 7 squared. When we simplify, we have to subtract the 9. When we subtract the 9, we have x squared equals 40. We now need to simplify the square root of 40. And that can be broken down square root of 4 times the square root of 10. Final answer, 2 radical 10. The last example gives you a radical as one of the sides. So when we have to set our equation up, when we multiply that, you're taking 2 radical 3 times 2 radical 3. That would just multiply what's on the outside. 2 times 2 is 4. Radical 3 times radical 3 is 3. 4 times 3 is 12. So that's how I got the x squared plus 12 equals 100. Subtract the 12 gives us 88. Now take the square root of 88 gives us 2 radical 22. As you can see, we are going to have quite a bit of work with square roots, simplifying radicals, and that's going to be a big part of why we are reviewing this. Let's move on to one of our special triangles. The special triangles, 30, 60, 90. Anytime you have a 30-degree angle or a 60-degree angle in a right triangle, that's when we want to use this. The terminology, we have a short leg, which is always opposite the 30-degree angle, a longer leg, which is always opposite the 60-degree angle. The hypotenuse is opposite the right angle. 2 rules. The hypotenuse is equal to the short leg times 2. The longer leg is equal to the short leg times radical 3. Those are the 2 rules that we have. Depending on which side is given, we have to be able to apply this. So what we have in the first example, we are given the hypotenuse. So it is best to find the shortest leg. We can take half of that hypotenuse. So half of 12 is 6. The short leg is opposite the 30-degree angle, so that would make it x equals 6. Multiply that by radical 3 gives us y equals 6 radical 3. Then you can follow in the second one. We are given a 60-degree angle marked. Well, both of the sides are equal to, or the short side is 4. So what we can do is find the hypotenuse. We can just double that using our formula, short leg times 2. So 4 times 2 is 8. So x would be 8. Take the short side times radical 3. 4 times radical 3. So y is 4 radical 3. Now, it becomes a little more difficult when you are given a radical as a hypotenuse. What we have is 5 radical 3. Take half of that. Well, half of 5 is a fraction, so just write it as a fraction, 5 radical 3 over 2. And then we can just take that times radical 3. You can see that that's going to give us 5 times radical 3 times radical 3, which would be 15 over 2. So therefore then in the next one, we have 8 is given as the longer leg. So to find the shorter leg from the longer leg, we have to divide by radical 3. Remember, when we do this, we can never leave a radical on the bottom of a fraction. We must rationalize it. So we multiply by radical 3 over radical 3, and then that can be simplified as is shown. On the next one, we have the short leg is given to us as 6 radical 5. All we have to do is be able to multiply that by 2 to get the hypotenuse, and multiply it by radical 3 to get the other part. Okay, we've got a couple more things to go over. As we take a look into the next special triangle, it is a 45, 45, 90 triangle. So whenever we have the two legs being equal length, the two angles being the same, that's when we're trying to be able to use this. We have one rule for the 45, 45, 90. The hypotenuse is equal to the leg times radical 2. Now you're going to have to study these and make sure that you can keep those rules where you understand them and be able to apply them. Some examples here. You're given one of the legs is 8, so you would know the other leg is 8 because both of them have to be the same. Just multiply that by radical 2. So 8 radical 2 for the hypotenuse. Second example, you're given a hypotenuse is 4. So what we need to do, we're given the leg is 3 radical 6. The other leg would be the same. What we now need to do is to multiply that by radical 2. When we do, we get 3 radical 12. Can you simplify radical 12? Yeah, you can break it down as square root of 4, square root of 3. That becomes 3 times 2 times radical 3, so 6 radical 3. For the third example, we're given the hypotenuse is 10. We need to divide by radical 2. Can't leave a radical on the bottom, so rationalize. Show the work that you have 10 radical 2 over 2. The 10 and 2 can cancel, giving us 5 radical 2 for each of the legs. And then the last one, you're given a radical, 8 radical 5. Just divide it by radical 2. Rationalize your denominator once again, and you can see that you're coming out with what the answers would be. So there's a lot of work with radicals as we go through this. The last part is the right triangle trig. It comes back to where we have been using our definitions using SOHCAHTOA. Given an angle, and that symbol in there is called theta. So as we use that, we have either the adjacent leg, the opposite leg, and the hypotenuse. It's all based on the location of the angle. Is it right next to it? Is it opposite? Hypotenuse will always be the side opposite the right angle. Our rules for this, SOHCAHTOA. If you learn how to spell that correctly, it tells you what your definitions are. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent is equal to opposite over adjacent. Now, I've set up several different examples down below. We are given the triangle, and you can see that we have a 23-degree angle. One side is 6. Can we find the other two? Well, what we have to do is set up two separate equations. To find x, that is opposite, 6 is adjacent. So that tells us we would use tangent. So tangent 23 equals x over 6. What we need to do is to cross multiply. When we cross multiply, that would give us our answer. You will use your calculator. Make sure your calculator is in degree mode, and then you can just type it in just the way it is. 6 times tangent 23. Now, moving on to the second part to find y, that's the hypotenuse. What we want to be able to do is we have the adjacent leg 6, hypotenuse is y, so we can set that up when we cross multiply. This time we have to divide 6 by cosine 23. Type that in, you get your answer. Looking at the next examples, you can kind of follow through, see which sides are given as to which trig function you're going to use. You will apply your sines, your cosines, your tangents based on which sides are given and the way that those will be set up. If you have questions, make sure that you contact me. You'll be doing some assignments on Delta Math today. Thank you.